Welcome back, 8th grade. So we are working with square root functions. And we have simplified square root expressions or radical expressions. We have solved radical equations, and now we are going to graph radical functions, which are radical equations. Now, to make this a function, we can only have our range above a certain point. So our range can't be negative. I want to say can't be negative. Our range is only the top half of our shape. So, and we'll talk about what the shape of the graph is going to look like in just a moment. But there are some restrictions to square root functions. All right, so key concept. A square root function is a function containing a square root with the independent variable in the radicand, and then our parent square root function is y equals x, the square root of x. So on this slide we have a picture of a table and of the parent function and the graph of that parent function. If you notice, we are all positive y values, so our range is positive at this point. We are currently starting at 0, 0, at least for these first several. We're going to talk about how we shift this graph in different ways. But if you notice, it's half a parabola. So thinking back when we were doing quadratics were parabolas, those U-shaped graphs. And then we've also talked about how square roots are the inverse operation to squaring a function. And so it makes sense that when we take the square root, we're just taking our parabola and turning it 90 degrees. Now, for it to be a function, I can't keep both sides of the parabola. So we only have half of the parabola so that it's still a function. Because remember, for it to be a function, for every x, there can only be one y. And if we kept both sides of the parabola, for every x would have two y's. And then that would not be a function. So that's where we're starting today. Parent function's good to know. I would probably keep this table somewhere close to you, your notes nearby, that type of stuff, because actually having this table is going to be pretty handy. We are going to talk about domain. All right, so when we're talking about our domain, what we cannot have is an x that allows the inside to be negative, right? So we have to have a radicand, right? That inside has to be greater than or equal to 0. So to find our domain, we just have to solve to make sure the radicand is greater than or equal to 0. So I'm going to add 9, so we're left with 3x is greater than or equal to 9, and then divide by 3, so x is greater than or equal to 3. And so for this one, our domain has to be greater than or equal to 3. Anything less than 3 will make that parabola or the radicand negative, which will make it unable to have real solutions and therefore not part of our graph. So domain has to keep the inside of our radical positive. All right, so we are going to graph. So we have 2 steps when graphing. Step 1, make a table. There's no real true easy thing than to just make a table of points. So we have our x and our y. Because there's no plus or minus or other multiplication going in on inside the radicand with that p, just going to start at 0. From the textbook, for what we're working with are amperes and watts and power and all of that. We are going to go with, and I'm calling that X, but I guess technically that's P, and this one's I, but we're going to go with 0, 10, 50, and 100. And I'm going to let, again, I'm not the one choosing the points. The textbook shows the points, but when we're working with watts and amperage, bigger numbers help us get further. I'll talk about when we get to a different one how I think about X values to choose. All right, so when I plug in, because that's how we get our Y, or in this case our I values, we're going to do 1/5 of the square root of 0, right? Square root of 0 is 0, 1/5 of 0 is 0, right? And then we're going to do 1/5 of the square root of 10. So I plug that into the calculator and I end up with 0.6. I do 1/5 of the square root of 50 and I end up with, plug it all into the calculator, I get 1.4. And then 1/5 of the square root of 100. Well, easily 100 is 10, so I have 1/5 of 10, which is 2. Now those are my points. Step 2, graph the points. That's all that it is. So I'm going to count by 10s across the bottom, so that would be 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. And I'm going to count by half points going up. So this would be every 2 is 1. So 1, 2, that's going to be my 3, 4, 5, so on. All right, from here we just graph our points. So we have a point at 0, 0. Oh, please don't do that to me. 0, 0. 1 at 10, comma 0.6. So if this is 0.5, we're just above that. 50, so all the way up here to 50, and then 1.4, so just below the 0.5. And then for 100, we're going all the way up to 2. So that's 1, 2. And then we draw our half U shape, preferably through the points. Now, when you're doing this in Math Excel, you just need that vertex point and then a second point. I think most of Math Excels are choosing the graph, so multiple choice, but just in case it's not. That's what you do. All right. So that's how we graph a function. In the next video, we're going to talk about what if our function does not start at 0, 0, and I'll also talk about how I tend to choose the X values. So I'll see you there.